Moving right along. The next item in our agenda is a keynote speech by Professor Nagesh Murthy under the topic of managing overlapping of activities in cyclical projects under stochastic task environments, illustrated using the context of vaccine development for the COVID-19 pandemic. To give a small introduction to Professor Murthy, let me now invite Dr. Chamila Walgampaya, who is one of the Vice President of the Central Chapter of CILT Sri Lanka and a Senior Lecturer at the Faculty of Engineering, University of Peradeniya, Sri Lanka.
Thank you, Smithya. It is indeed a pleasure to introduce today's keynote speaker, Professor Nagesh Murthy. Professor Nagesh is the Roger Engemann Professor in the Department of Operations and Business Analytics at the Lundquist College of Business, University of Oregon. His prior work experience includes faculty positions at Michigan State University and Georgia Institute of Technology. He is currently the Associate Executive Director of FORMS for Global Initiatives and Outreach. His passion is to engage with the industry for experiential education, research, placement, and alumni outreach. He has worked with major manufacturing firms in the Pacific Northwest, industry consortia, and governmental and nonprofit agencies to foster university, industry, government partnerships for enhancing innovation, sustainability, and competitiveness for the manufacturing sector in the region. His empirical and normative research has been supported by major grants from firms, industry consortia, and government agencies. His research has appeared in management science, manufacturing and service operations management, production and operations management, Journal of Operations Management, decision sciences, and naval research logistics, among others. He has won several best paper awards at the annual meetings of the Decision Sciences Institute. Over to you, Professor Nagesh Murthy.
Thank you for the kind introduction. Can you hear me clearly? Okay, somebody let me know otherwise.
Oh, thank you. Of course.
Thank you. Yeah. Once again, thank you for that kind introduction. First of all, good morning to everyone. Greetings from Eugene, Oregon. For people who don't know what Oregon is or where it is just like Sri Lanka. Extremely green and extremely beautiful. So it's one of those places where when I came to Sri Lanka, I thought it just looks like Oregon. So it's my distinct honor to be invited to this 2021 International Conference on Logistics and Supply Chain Engineering. I want to thank the organizing committee for hosting and organizing this wonderful conference and managing all the logistics for this meeting in these unprecedented times. What draws me to this conference most is that I have very vivid memories of visiting Sri Lanka and attending the POMS International Conference hosted by the University of Peradeniya in December 2019, and subsequently developing enduring friendships with several faculty and also members of CILT. I was also very, very impressed and inspired by the academic culture in Sri Lanka, wherein the manufacturing industrial engineering departments and universities organize academic conferences in close collaboration with industry professionals. This is sometimes not what happens in the US. We are too bifurcated sometimes. So again, it is my distinct pleasure to welcome you all to this conference. At this point, I would like to recognize all the dignitaries of the conference. Dr. Dato, CILT International President, Mr. Chanaka Duyalvis, CILT Sri Lanka President, board members of all CILT Sri Lanka Central Chapter, Gayani Duyalvis, and all of the dignitaries from university and industry. And lastly, I would also like to explicitly recognize the members of the conference organizing committee, Dr. Asila Kuratunga, Dr. Prasanna Elakun, Dr. K. Jayakrishna, Dr. Subodha Dharmapriya, and Mr. Namal Bandarnaike. I'm sure many other faculty, graduate students, and other staff too have worked tirelessly behind the scenes. The conference indeed has an exciting program schedule. So once again, it is my honor to be part of this ceremony, and I hope you all will have a wonderful experience. So with that, what I will do is I'll switch over to my talk for this morning for you, evening for me here. So let me get set here. I'm going to share the screen. It takes a few seconds here. Let me do that. Are folks able to see my screen? If somebody can let me know.
Of course, sir, we can see it.
Thank you so much. Okay, yeah. So when I was asked to give this keynote talk, I, as a research faculty, get very nervous because I've given very few keynote talks, and I wonder if what I have to say, in ways I say it, is that appropriate for the audience? But having been to Sri Lanka before and seeing how the university industry works together, I thought, let me pick something where in supply chain logistics, we generally think a lot about once the product is manufactured or is being done from the supply chain tiers and how it moves through and how we can do it cheaper, faster, better, and more sustainable and so on. But there's one part of the supply chain which sometimes gets less attention, and that is the intricacies of its linkages with the product development process itself, and how sometimes the fate of the product and its ability to be moved through the supply chain is sealed by fundamentally what happens in that stage. So as I was thinking about it, and this is the time of the pandemic, I thought, what if I focused on how exactly vaccines got developed? The vaccines up until last year were developed in very different ways. And because of the pandemic and the time pressures, one had to shift gears a lot. So in supply chains today, what we've seen in the last 2 years is shifting gears is a major challenge. And that means everybody is engaged in projects of how to figure things out. So I thought that maybe we have got wonderful keynote speakers who perhaps will talk a lot more about the supply chain logistics aspects. I thought I would just focus on the front end and tell a story where research meets reality in terms of contributing to advancing our understanding of how to manage supply chains. So that's the basic motivation why I picked this topic. So now the question becomes, if you look at the vaccine development projects over the last 40, 50 years, the typical time, average time to develop a vaccine and successfully have it in the arms of patients has been typically 11 years. So what you find is that this is a highly regulatory process, which means one has to go through step by step by step by step by step process to really satisfy the requirements of regulators who want to make sure that nothing unsafe gets into the market. And these regulators also vary in requirements across the globe. So it may be okay in one country, but may not be okay in another country. So what it means is that you've got to go through all these processes. So if you look at all the stakeholders, obviously we are the ones as community who receive these things, but it's the pharmaceutical companies, it's the government agencies, nonprofits, and then the need for, how to make this viable. Who's going to fund all this? Why should the pharmaceuticals do it if there's no money for them? Why would the governments do it? Because it's not about money. It's about saving the community. So what you find is in the past, the pressure has never been, although there has been in many cases, but it has never been universally like what we've seen in the case of the pandemic. And so there was a tremendous urgency to say, there is no way we can do this in the old paradigm. So even people who had no supply chain experience, the people from the medical industry began to realize, doctors, public health people, that this has got to change. So even in the journals, which are the front end of where people test and show and write that this works or doesn't work, what the efficacy is and so on, they realize it's not as much about just the science of it. It is also going to be about how we will actually get this done. So they began to, without having any experience in concurrent engineering or simultaneous engineering, said that we need to change the rules in dramatically different ways. We can no longer afford to do this sequentially. And they proposed all kinds of ideas. And what you find is that within a limited number of months, between January and March of 2020, everybody realized, all players, government agencies, anybody and everybody across the globe, stakeholders realized that this cannot be managed at a company level or just at a country level. This has got to be an international effort, a very coordinated effort, but something which can be done safely and in a speedy and effective manner. So that thing, what happened is, it fundamentally changed the game. The whole calculus of how projects get evaluated, what the metrics are, and how will we make this happen, changed. So the first thing what happened is, the level of funding that got poured in by the companies themselves and by the government agencies across, mainly in the developed countries, allowed these companies now to do things in ways they could have never thought in the past. And they began to now overlap activities. Not because they had some fundamental analytics to know and learn. It was just the only option. And what happens miraculously is that in vaccines which have taken 11 years on an average, suddenly now, within 9 months, within 14 days or 15 days or 20 days, they decode everything that is required at the digital level. Now, once you know everything that happens in the science, the digital world, the rest of it is go make it happen, go test it and go make it happen, which is the world of the trials and then all the making doses available, the manufacturing, large scale ramp up and so on. So if you notice that in this slide, even in 2020, early part, they did not think logistics was going to matter much. They just thought, oh, it's all about small scale manufacturing for trials and large scale ramp up. They knew one thing for sure, that we'll be making vaccines in numbers far, far, far higher than any time in the past. That they knew. You can see the boxes when they draw these diagrams. They recognize what things will be large. But they had no idea at that point in time that they would also need to worry about logistics. The mRNA technology was developed well in the labs, was never tested large scale, but seemed like a breakthrough option. And then you suddenly, as an afterthought in the midway, you realize these vaccines need to be stored at temperatures we have never moved things in. So whole notion of cold supply chains and so on. So what you can see is that even when we're in the thick of the pandemic, people are not seeing the entire view, but smart people, hardworking people, committed people are figuring all these things out. So that's the reason I thought that maybe the vaccine development project might be one example of where we can see the world of digitalization, the world of predictive prescriptive analytics, and the world of stakeholders coming together in ways which is unprecedented. All that comes into play. And that for us as researchers, makes us ask a question, it seemed to have worked, but would this work in all the environments? How would we know if it will work or not? Can we rely on some analytics or some other guiding principles which could have told us, yes, it could make sense, or no, it may not make sense? So these kinds of phenomenon for us in academia allow us a little bit more it piques our interest in trying to understand. So how is this working? And so on. So which means that, so you can see all this overlapping taking place without any tools. There are no tools guiding these things. Project management as a field itself, if you look at supply chain management, very, very advanced in analytics. But project management as a field still is much more art than science. And so this became a kind of interesting opportunity to think of what else could we do. And so if you think of now, so I'll come down to this notion of what is acyclical projects, because this is a academic word. This is not an industry word because this is something which is still in early stage of conversation between academia and industry. So what it means is all the projects we think about traditionally for the last hundreds of years basically have activities and you have precedence relationship. We teach our students all the time. We have packages doing this for our professionals. They use all these tools and plan and replan and manage their projects. So what it essentially is that if you have a activity which is succeeding after this one, first one, you cannot start this till this is done. So the notion of somehow breaking this and overlapping is something which does not materialize in a lot of environments. But there's a special class of environments where we looked in the last 30 years, where these acyclical projects look something very different. So if you look at from over the last 30 years or 35 years, how many physical, discrete, engineered and manufactured products, their product and process development projects have evolved. They broke from that paradigm and they said, we can't do this sequentially, it takes too much time. So smart people began to modularize the architecture, and that allows many more things in parallel. That allows for compression of time. But then one more thing which was recognized was that, in spite of that, there'll always be one activity which needs to be done for the next. So the next activity is just waiting for the specs. If I'm designing an engine with certain geometry, I cannot do that completely unless I know what else goes into the hood under the car. Space matters. So unless all other specs are getting finalized, I can't do something like this. So these kind of restrictions are purely because of the specs not being finalized. Till the smart people recognize in simultaneous engineering for overlapping, we can take a gamble. Can we do something before we know what exactly it's going to be? And then, of course, for that, you need tremendous coordination. It takes time and money. That takes more time. Overlapping saves you time, but the coordination takes time. So there's some give and take. But then because you are gambling, you are constantly reiterating, reworking. So what they figured out is that there's a whole new world of analytics and project management. This came out of about MIT about 25 years back. So they coined this new challenge of how to think about these cyclical projects, because they're all much more information-based. And you can gamble and start the succeeding one before the preceding is done. And then, of course, you get something, you give something. By starting early, you may save some completion time, but because of coordination costs, rework, you will lose some time. So you may gain sometimes, you will lose sometimes. And the last thing to recognize is that the vaccine development projects are very much like the projects we have done for these physical products over the last 35 years. But I don't think this planning for vaccine development was done with this knowledge in mind. We were only in a bind, and so we did it this way because there was no other way feasible to actually do things in time. So you can see that there's an opportunity to take that literature, which was developed in a totally different context, and then try to understand how can we understand the vaccine development process and offer more guidance from prescriptive analytics. So in a very simple way, so ignore all the symbols and all that, that doesn't matter much. So there's always going to be something preceding and something succeeding. The preceding task takes its own time when it has all the information. The succeeding task, if done afterwards, takes its own time. But if you start the preceding task before the succeeding task, before preceding is done, then what you have is some rework because you gambled. And even though you're coordinating, every time you work with imperfect information, some redo, possibly. So in this one, you got to think of what the trade-offs are. And none of the project management tools that we do today for traditional methods, these ideas cannot be used there. So it requires a very different kind of thinking. And so we transfer from something we learned in the automotive sector and other products and bring it back to the vaccine development idea. So that's just the idea of that when you start something early, you save time because this from here to here can go down, but then you also have some gamble of losing things. So that's the trade-off I need to think about. So the second thing is, for some reason, for the last 25 years, we always kept things simple. Assume this task is known in time. This task is known in time. And then you try to figure out, how much to overlap, when to overlap, and not to overlap. So what you would find is that if you keep the task duration deterministic, then you would never overlap if the rework is larger than the savings. If this overlap and this is larger, you would never do it. And so people stop there. The beauty of it is when the world is stochastic, we don't know how long phase one trial will take. We don't know how long phase two trial will take because it's all the doses that you've got to try. The escalation trial for doses have to happen in a safe manner. If something goes wrong, back to square one. So there's a lot of back to square one. Because of that, the uncertainty in generally vaccine and therapeutic development projects is very high. So all we have to see is, can we extend that to stochastic environments where uncertainty is high? Can we learn something new? And can we explain why in this environment of vaccines, it happened to work out? So that was the motivation for this. And so these projects are called cyclical projects. So previous research was all deterministic and stochastic will bring new insights. Stochastic means when things are uncertain. And the goal that we do in this particular work is minimize expected completion time. Because in vaccine environments, how fast you can develop. The time was of essence, right? That's why we call it as development projects at pandemic speed. We coined all kinds of new words. In the US, we also call it warp speed. They all mean basically time matters. So the objective should be, at least one of the objectives should be minimizing expected completion times. In these cases, money was no object, at least this time, because everybody poured in enough funds. The goal was get this done with the efficacy standards in the least amount of time. So that's again the motivation for, but there's one thing which is different between car manufacturing and this. Although in car manufacturing, safety is very important, but you cannot associate safety with every single module in the car. In the case of vaccines, you have to ensure that all phases of vaccine development actually resulted in outcomes which were deemed to be safe and also efficacious in all those stages. So there are certain kinds of restrictions that you bring in. And as if you are kind of a modeling kind of person, you realize that this mathematics starts getting more interesting. And the goal is not mathematics. The goal is what can we learn? So the vaccine development environment poses something new, interesting, and different in that sense. So the key thing is when you overlap activities, you just know when you'll start the second one. You don't know when the first one ends. So you don't know how much overlap is. So the overlap also is uncertain, which means the rework cost also is uncertain. You don't know that. And I'll not, so, but the other thing to recognize is when you gamble, you may win or you may lose. In the old way of thinking, when you put just some times into project management tool, you would never do things if you were a net loss. You would only do net gain. But what happens is when you get to stochastic, the first insight, which is easy to understand once you see the mechanics, is that you can actually gamble well and be a winner, even if you were in a net loss situation. So that seems intriguing. I'll show a little bit more of what the kind of insight for that is. The last thing is this. For all those project managers, we know that in projects, sometimes once you draw a schedule, you hope that things will work out closely. So you've got multiple resources, shared resources. You can't move people around very dramatically. So resource flexibility may be low. In other environments, the priority is, if something finishes earlier, we will shift to earlier. And that means you're going to invest more in resources. So you may have a relatively flexible resource environment in which you can reschedule projects more easily. Or you may have relatively inflexible environment wherein it is hard, it's costly. And so when we model these things, we want to understand all those scenarios to keep things in mind. I'm going to keep a track of my time here because as teachers, we sometimes don't have clocks, but I've kept a clock in front of me. So again, I'm going to hide all the math and just get to what we are doing and what is the goal. So if you look at project management objectives for something like vaccine development, you would want to minimize expected completion time, right? In budget constrained or unconstrained environments. It so happened that vaccine development was a bit more unconstrained than some other therapeutic development projects. Sometimes you have a goal. I need to get this out by this date, right? Politicians will promise, we'll be ready by this date, or we'll be here by this date. Then it's all about maximizing chance of completing the project within that promised date. Of course, then you've got time cost trade-offs, time performance trade-offs, all kinds of things. So as practitioners, you have a lot of things to juggle, which means that the science of it needs to also be able to develop these things, not just one researcher, but a team of researchers over time begin to pick all these problems and create a body of knowledge, which then becomes useful for practitioners. So now you wonder, okay, even if we develop some magical way of saying how much to overlap, that's an optimal overlap, meaning that's the best overlap, which basically minimizes completion time. As executives, you always want to know, how do I know this is the best one? What do I compare it against? So then we say, okay, how about the many comparisons? But one of them you could say is that when task times are stochastic, when I go to practitioners, they all say, I'm going to work with one number. In Microsoft project, whatever tool you have, I'll put, it takes 10 weeks or 50 weeks. So you work, in that case, what you're doing is you're working with expected time and planning everything around expected time because nobody has a crystal ball. Some other people say, you know what? We are a very nimble organization. We can plan at a certain point in time, but if the preceding task ends early, we can shift resources very well. So I would like your policy to compare against that policy where I'm in a resource flexible environment. So these are typically kinds of things which academicians like us do to create some comparisons to see what the benefit is as a first cut. So as a big picture thing, think of 2 by 2. On one hand, I may be an organization which has low rescheduling flexibility. All my resources are shared. Just because this one wants early, it's already committed somewhere else, so I can't do it. So you may be either in a low flexibility environment or high flexibility for rescheduling. Or in this case of gambling, doing things before you have all the information. Sometimes the gamble pays well because the downstream stage is not as sensitive to not having good information upstream stage. So you may be net gain. In other times, you have to backtrack a lot and net loss. So in the vaccine environment, think of the following examples, right? Moderna and Pfizer, they lucked out quite well because they came up with their vaccines and they, although they had different efficacy issues, perhaps, they also had different levels of readiness. I think Pfizer ran a little faster, at least in the US. So it worked out that they gambled on investing in those processes for mRNAs, even when the other things were early stages. And things got approved, it was working well, so they were able to finish it much faster, right? If you think of Johnson & Johnson, different kind of vaccine, different kind of process technology. And here now, because they were a bit late to the race, they also had a few hiccups. And then suddenly some countries want it, some countries don't want it. Can you imagine the amount of chaos it causes for having invested all in the manufacturing process and then not have the chance to actually reap it? Means it's more of a situation of perhaps net loss for having gambled early. So nobody can predict, but in general, you could fall in either cases. So that's that. So now, without spending more than 20 seconds, there are a lot of very smart people over the last 20 years have done wonderful, rigorous work, mainly emanating from the group at MIT, which has been at the leading front for all these concurrent engineering and product process overlaps, improving design architectures, and so on and so forth. But unfortunately, the work stopped a lot on that level at deterministic tasks. So what we figured is that there's a huge gap, and the vaccine development project is a classic example of you never know till it happens. Whether it works or not, you only know when it works. If it's not, next idea, next idea, next idea. So we thought that maybe looking at this and trying to understand in stochastic environments was a good opportunity to advance the literature, and that's how we began this project. So now if you think of any project, traditional project, you know that either there are one-to-one relationship, one starts, next gets started, or one start finishes, many can start, or one, many finish, one can start. So these one-to-one, n-to-one, one-to-n are the building blocks. If I can somehow develop some know-how for these, then I can embed these ideas into any network and then perhaps begin to give ideas to enable project managers to understand how to manage risk in this kind of environment. So it's a planning tool. So now if you look at how to develop some insights, I'm looking at my time clock here at 15 minutes. I will stop no matter what at the end of about 10 minutes. So we can have some questions. You're generally getting the idea is to develop some thinking and methodology of how to analyze this problem. So if you have two tasks overlap, you don't know how much it will be because you don't know when the first one ends. You only decide when to start this. Forget all that. So again, you can either be in a winning situation or losing situation. So we have to parameterize. So as a manager, I tell the following, right? If you have an overlap of something, if you lose all of that, exactly that much, you gain nothing, then I call that the multiplier is 1. If you had some overlap to save time, but you only lost 80%, which means 20% gain. So any number between 0 and 1 for this C parameter means you are gaining. Any number between 1 and beyond means it's taking more time. If C is greater than 1 here, whatever overlap was, your rework and other things cost a lot more. So situation of gain when this number is between 0 and 1. Situation of loss when this number is greater than 1. So that's the only simplistic. We want to keep the idea very simplistic and see how much we can analyze. And also, these tasks, we know the minimum, maximum of each time. So there's a little bit of technical things that we put in the paper, but essentially to make things comparable. So again, I want to explain, when would you lose? Johnson & Johnson, right? You develop a vaccine and then suddenly hiccups. And then something else takes off more. So all the capacity that you invest may not be reaped in a reasonable amount of time. And the same thing happened for some other vaccines from UK and beyond, right? So that challenge can be a winning situation, or you can be in a losing situation. Doesn't matter. As researchers, what we do is, and then the other thing very important is, if you have an upstream task, this is important technically, this task is here, you are gambling, starting this early. Because of vaccine efficacy requirements, no government will approve unless each stage has met its performance mark. So the time taken to meet a performance mark is none. You cannot negotiate a performance. So because of that, what we always say is, don't get too anxious or too optimistic. If this is a very small activity, you can't move it all the way back and think, I'll finish it and done. No, because this activity depends on information on this. So the second activity cannot finish before the first is done, because the second activity only has information after everything from the first one. So those restrictions create some kind of interesting things. So I'm going to skip some things here. So the first thing is, the biggest insight, which is counterintuitive, is in all those situations of loss, C1, 1.1 means you overlapped something and you basically lost 110% of that. You overlapped, 2.5 means you lost 250. If you overlapped by 2 weeks, you lost 2 weeks at 2.5, right? You lost 5 weeks. So all these situations, if tasks were deterministic, no manager in the right mind would approve it. But when somebody sees there's an educated gamble to be played here, and that is the mechanics of all the math, which I'm not going to talk about here, but trust me, there's a gamble that you can play here, which allows us to now start saying what would be the optimal overlap based on some stochastic kind of analysis, and what would be the optimal start time. The manager, without this tool, may say, you know what, I'm going to start at expected completion times of previous ones and live with that. And now here we're telling the optimal start times. So you end up saving, in this small example, in cases which deterministic tasks would never show savings, but in stochastic environments, these bad situations still are gold, worth going through. So that tells you that stochastic analysis gives new insights to project managers, which sometimes are not manifesting in a very deterministic thing. Some other things. So now you know that if you overlap too much, it's going to take more time. So this blue one is how much time it takes in expectation. So as you get to the optimal one, lowest time. But if you delay, more time. So you might have one level of overlap based on analytics for optimizing, minimizing completion time. But managers don't just care about completion time, right? Governments want risk. So what you notice that the variance of completion time is constantly decreasing as you delay overlap. So if you want the goal, if it's minimize expected completion time, you'd be at 2.5 should be overlap, starting fine. But if the goal is no, that also has very high risk. I want to bring the risk further down, which means you will compromise some combination of a bit more time to complete, but bit less risk. So that time risk trade-off can be looked at through the diagrams, and agency stakeholders can make their own decisions in terms of, based on resources, what combination to look at. So, and again, if you have similar different objective of chance of completion, you have similar kind of analysis possible. So what we do is do some underlying mathematical thinking, which allows us to answer questions that a manager may care about vis-a-vis their current practices. Now, so now I have got another 7 minutes, and then I will stop for 5 minutes for questions. Remember I said we will analyze this for environments where flexibility is low and environments where flexibility is high. It so happens that there's one more thing which matters. Is the preceding task a big task or succeeding task a big task? It can be one way or the other way, two cases. So if we have resource inflexible environments, and if you're looking at this small example, so in project management, we teach, and managers also will use PERT, all kinds of triangle distributions, PERT distributions. So let's say there's a distribution which says it's a triangle distribution, minimum is 15, maximum 20, and the peak is 18. This is taking quite a bit of time. This is a small task. So because this task takes small time than this time all the time, so you have one condition. You cannot finish the project till both are done, which means if you thought, oh, and this is the axis of gain. This C-axis means, C0 means no penalty whatsoever. You gain everything. C1 means whatever you overlap, you lost all of it. C2 means whatever you overlap, you lost twice. So anything less than 1 is gain, anything greater than 1 is loss. So again, what it shows you that you cannot start anytime you want, because if you start too early, then you will violate the condition that you should finish, at no time before the previous task. So these vaccine requirements at the end of the day pose these kind of things. So what we do in this kind of thinking is 2 questions. If I know the task that you have in your project, what should be the optimal planned time, starting time for the second one, and what will it be when it's gain situation, when it's loss situation, exactly when to start. It tells based on something which minimizes expected completion time. Similarly, that shows you basically what would be the outcome of this. This is when to start, and this is basically at the end of it, having started at the optimal times, what the optimal completion times would be. You can see all kinds of variations. This is something where human beings are not hardwired for analyzing risk in all these kind of quirky ways. So the tools of predictive and prescriptive analytics going forward will help. So for example, after having done so many projects over time, if all I care about when I gamble, am I winning or am I losing? And if I have some idea of what to expect in a particular situation, all I need to know is what is my expectation of that number and what should I do? So this idea can be taken to a more realistic scenario. So we have developed this for 2 tasks when it's flexible, non-flexible. Second one takes more time, less time, all combinations, and assume that this gives us some kind of insights on how to deal with it. So this way we know exactly, given these things, how to deal with 2 tasks. That's one building Lego block of understanding. I'm going to keep moving because this takes more time to explain. Then I can also see when it's helpful, and it shows that under what conditions you actually end up saving for flexibility. Because as a manager, I want to know, should I invest in flexible resources or not? So we can even tell you, if your conditions are this, flexibility doesn't matter. If your conditions are this, flexibility matters. So it kind of gives managers also guidance in terms of structuring the resources. As you can tell that I got to develop the same complicated thing for 1 to n and n to 1. Assume that we have found a way to do it, and all that is something which is academic curiosity, but let's say it's done. So what? Now we say, how will it work? So we say, let's try it on some projects, some simulated projects. The first example is a small project where it has some things which are 1 to 1, some things 1 to n, which will be 1 to 2 here, then 2 to 1, purely sequential project. So then we say, okay, if you did the traditional ways with all the benchmarking policies and did this way, how much would you save? So those are some curiosities. Again, as academicians, we have the burden of how good is it? Does it matter? So the ability to analyze these things becomes important to have some guidance for the practitioners. So then we have looked at, first of all, because this is a complicated heuristic. So first worry for academicians is how close is it to the optimal? So the optimality gaps are low, meaning for practical purposes, it works well in terms of finding the optimal. The second thing is all about, how much should I invest in flexibility or not? How much would I gain if I go with the traditional way with no analytics and put something like this? So we provide the contrast, and you can say that the savings are substantial. And in this example, I can create other examples where savings could be very large. And in some examples, the savings could be not as large. So that is the kind of analysis which can be done for any real world example from the industry data. And the manager's perception of how much they think there'll be gain or loss by overlapping or not overlapping. Of course, the vaccine development project is a complex project. If people are managing at the highest level, let's say WHO, pharmaceutical companies, countries engaged in it, that project management is at a very high level. But if you get down to somebody managing a phase, There's lots of moving parts. So sub-projects within sub-projects within sub-projects, but they all will have some complexity like this. So how do we take those building Lego blocks and take them to something, to an implementable large-scale problem? So we need to develop a heuristic. So we have in the paper, we kind of do all those things. So essentially what I'm getting at is that by understanding the basic building blocks, understanding what the give and take is, understanding what the intuition can be, because no manager is going to implement anything unless you can appeal to their intuition and say, oh yeah, okay, now I see why. So we have to have all those now I see why if you're going to guide anybody to deviate from something more traditional. So a tool like this is not the only tool. I'm sure many researchers will work on problems like this and make things better for some situations versus other, but this is the start. So our paper is the first one to do this kind of stochastic thinking as a starting point to create this conversation. So at the end of the day, I'm surprised I'm on time here, so we've gone through this whole exercise with the goal of trying to create some understanding for those kind of projects wherein there might be a strong linkage between the gambling you have to take in the product development, process development, logistics development. You can see all those cold chains which got developed in some extreme cases. In some countries, those cold chains are not as much required because the vaccines don't need to be stored at those levels. So what you can do for developing countries, underdeveloped countries, the populations where things are much more dense versus distributed, the supply chain challenges are very many. And so the understanding the link between the product development processes, the manufacturing processes, the distribution processes, all those things, how much to gamble, when to set up, when to not set up, ideas can be explored as a guiding point. This is not going to give an answer, but it definitely facilitates a conversation for executives and managers and stakeholders to think of how can, all the data and analytics help the stakeholders make better decisions. So that kind of was my motivation for sharing this with you. And the idea here is that clearly this can scale. We can do complex projects with heuristic. It doesn't explode in time because it's not combinatorial. And the second thing is the ideas here are not just limited to the vaccine industry. They can be applied to many other industries. So that is kind of the motivation for this talk. In a classroom, I would have let you interrupt 10 times, 15 times. I just had a time constraint. So please go ahead and ask me any questions if you have. Otherwise, I can also answer things personally via Zoom calls or emails. Thank you very much.
Thanks a lot, Prof Murthy. Thanks a lot. That was absolutely informative, and we really appreciate your keynote speech, actually. So you are full of energy, and I think you made us go like really live. So there could be some questions from the audience. So the audience can raise their hands if you have questions to ask from Prof Murthy, or else you can just type your questions. So we'll take the questions as you receive them. Sir, until you receive some questions from the audience, I have my own one.
Please go ahead.
So you have explained that, so it's kind of you are introducing parallelism into the entire project. So when you do that, especially in a project where the vaccines are developed, don't you think like when you incorporate, when you make phase 1, phase 2, so on and so forth parallel, don't you think it affects the quality of the vaccine? I mean, have you considered that?
No, good question. So think of it this way. So we are not saying you can make it parallel. We're saying when you can, when you can't. So the key thing is that sometimes the only condition is as follows. In vaccine development, every phase needs to be finished fully to its satisfaction. So even if you start the next one earlier and the first one is not done, you're not done. So which means that you cannot start something too early because it takes little time. No, because the second one requires the first one to be done. So when you put that constraint stochastically, we guarantee that there is no activity which is compromised. And by keeping that in mind, can we still gamble? So yeah, so we are putting a hard constraint that the no activity, so the project is not done till all activities have been done to their satisfaction, whatever the goal was, So yeah. So yeah,
Right.
it's a little bit more,
Right.
the intricacies are in the math. I don't think I can give a very convincing answer, but we put that condition to make sure that, yes, that is taken care of. So efficacy is not compromised. Efficacy is not compromised.
So it's like context dependent. The value of the C is context dependent, right? Very much.
Yes, yes. So as a manager, you have to know, and so,
Yeah.
so because as of now, we don't know what the C's are, right? But my view is that in the world of project management, so much data has been collected now. People will know going forward. You can analyze lots of projects and see in this situation, when we gambled, how much did we lose? How much did we not lose? So as we have more data-rich environments, the data mining technologies will tell you that if you're in this project, you should estimate your C to be 0.5 or 1.5. And then you decide whether you want to gamble or not. So I think this is ahead of the time, but going forward, the hope is that a lot of data which got buried in projects is now getting much more, mined, because there are agencies which feel the benefit of that. And so, yeah, so it's the idea is a bit ahead of the time in terms of how would a company know. As of now, the best thing is a manager's, experienced manager's intuition.
Of course, there's a big role to be played by data mining, people in data mining and machine learning, right?
Yes. Absolutely,
Yeah.
absolutely, yeah.
Yes. Thank you. So we have another question.
Okay.
It says, as you mentioned that analytics have not been used in project management. So as I think you have mentioned that in your presentation. So the question is, what kind of analytics are being used actually for decision making? I will simplify it like, what are the research potentials available?
Right. I think what I would say is that the amount of analytics that has already been created is far ahead of what gets used in the real world. They keep it simple, and it requires quite a bit of coaching, training, understanding. There are tools. The top large companies who have in-house operations research units, they have a much better chance. But as you get down to companies which don't have those in-house people with those technical skills and resources, in those companies, it is much more used as just plan once and then keep chasing and do whatever. If things go well, be happy. If things don't go well, chase and rearrange. So it's a bit more of, kind of ad hoc and not as much as planned. But that is changing. There are companies now doing AI-driven predictions of, if your budget is not used up this much, then your chance of being delayed so much. So I think the technology is coming, and I think the friendly technologies coming down in AI are more likely to be embraced going forward than the OR-based techniques. The goal of this paper is first to develop some insights of telling a manager, it makes sense to gamble even when you think you will lose. That is something which a manager would take it and say, then they will make their own decisions. Otherwise, they don't even know, why should we do it? Something must be wrong. And so I think the idea of risk-based analysis opens up some counterintuitive thinking for managers who then, once they understand, they reorient their paradigm and they think in different ways. Yeah.
Thank you, sir. I think that must have explained the person whoever posed the question.
And anybody can write to me an email, and I would respond to them. I will even talk to them on Zoom. So you can share my email. Asela can do that. Dr. Kulatunga can do that also, and I'd be happy to answer anybody's questions offline.
Sir, if we get questions from the audience, do you mind if we email you those things?
Please do, please do. And
easy,
just give me their contact information emails, and I will get in touch with them and answer their questions.
That would be easy for us, actually.
Yeah. If you have the chat window, you can copy that and then you keep it with you. And
we will do that, sir.
Yeah, I don't want to delay your thing. You are doing so wonderfully on time, and I've delayed you already by now 4 minutes, I think. So apologies for that.
Sure, sir. So thanks a lot again, sir.
Thank you.
Thank you very much. That marks the end of the Q&A session and the end of the keynote speech as well. So let me hand over the session to Ms. Smithya.
Thank you, Dr. Walgampaya, and thank you very much, Professor Murthy, for that enlightening presentation. Before we wind up this session, let me now invite Dr. Jailat Edirisinghe, who is the Vice President Outreach of the Central Chapter of CILT, Sri Lanka. He is also the Senior Lecturer at the Department of Civil Engineering, University of Peradeniya, Sri Lanka.
Extremely sorry. This happens very often when you go virtually. Good morning, everyone. Greetings from a beautiful city, Kandy, in Sri Lanka. I deem it a great honor and privilege to present in front of you, at least virtually, to deliver the word of thanks at this remarkable and memorable event. Needless to state the importance of the field of logistics and transport for economic and social development of a country. CILT, known as Chartered Institute of Logistics and Transport, plays a pivotal role in facilitating transport and logistics professionalism to the world. In that case, I have the immense pleasure and honor of recognizing the International President of CILT, Dr. T.S. Abdul Razak Abdul Malik. Your online presence and sharing your words of wisdom is an encouragement for the audience and a positive beginning to the conference. Presence, sharing the experience and guidance to the newly established branch of CILT Sri Lanka Central Chapter by the Sri Lankan President, CILT, Mr. Channakedi Alvis, is acknowledged and appreciated. Sir, we admire your kind cooperation for this conference. Captain of the ship, CILT Sri Lanka Central Chapter, Dr. Asela Kulatunga, contribution cannot be appreciated in few words. Anyway, I'd like to take this opportunity to thank for his commitment, leadership, and dedication for serving as a conference chair while playing the role of President, CILT Sri Lanka Central Chapter. Continuous assistance and support extended by the CILT Sri Lankan membership is especially noteworthy factor to mention here. Thank you all. Sponsors of the event, INSEE and Aquanet. Thank you for your generosity and assistance to make this a reality. The keynote speaker, Professor Nagesh Murthy. We appreciate your kindness and willingness to share your vast experience with the audience, and especially the time-relevant topic on project management with a case study for vaccine development for COVID-19 pandemic. It is indeed an honor and privilege to thank you for sharing your words of wisdom with the audience. Organizing committee had numerous assistance, cooperation during the process, being resource persons in workshops, collaboration for various joint programs are highly acknowledged and admired. I sincerely apologize for not being able to mention their identities individually. Technical sponsorship extended by University of Peradeniya, University of Sri Vajrayanathapuram, and Vellore Institute of Technology lifted the level of the conference to a high level. Finally, the technical staff, videography team, I appreciated for extending their professionalism to prepare conference material. You all, participants, presenters, panel members, and audience, without your participation, this wouldn't have had this glamour. I remain while wishing all of you a fruitful, successful, and educational conference. Thank you. Wish you a good day.
Thank you, Dr. Edirisinghe, for the word of thanks. This marks the end of the inauguration session. I kindly request all the participants to leave this Zoom and join the next technical sessions. Thank you.